All right, guys, so just effectively where we left off last time, we're going to talk through some trigonometry. So specifically, the basics of really what we need for this class is going to come down to using trig to figure out effectively the length of the opposite and then the adjacent. So if this is the angle of interest, our hypotenuse is the longest side of the triangle. The line right next to the angle that's not the hypotenuse is always going to be what's known as the adjacent. So you see the adjacent written there. From there, on the other side, we have the opposite. So when we have an angle and we use the sine function, we're looking at the opposite divided by the hypotenuse. When we're doing the cosine, we're looking at the adjacent divided by the hypotenuse. Now, the reason we care about this is because whenever we're going to be looking at the triangles effectively of our interest, we're going to be using this to break down those force vectors. So we're going to have effectively the vertical, we're going to have the horizontal. So hence, if we're doing a sine of 30 degrees, our x component is equal to the square root of 3 divided by 2. So that's the horizontal. And the vertical is equal to 1. Because you remember with the right angle triangle, we're always going to have a squared plus b squared equals c squared. And this is what's going to allow us to break down velocity into the vertical and horizontal, as well as force whenever we happen to be moving. So you're going to obviously have examples that you've already worked through on the math test, as well as you guys are going to work through obviously on your own today or whenever you listen to this without me. Now, remember here, guys, we have our wonderful math problems. Below, we have our basic information that I want you guys to go ahead and work on breaking down. So if it travels 800 meters in 3 seconds, how fast is it going and what angle was it initially fired at? Well, we're going to be using our distance formula, both horizontal distance and our vertical distance. So if it travels 800 meters in 3 seconds, well, we're just simply going to take 800 meters equals v, which we're trying to solve for, times 3. So we're going to factor that and we're going to find out our horizontal velocity. Now we need to find our vertical velocity of the initial release. So vertical distance, which is 0, because it obviously hits the ground, equals the initial velocity times time, which is 3 seconds, plus 1/2 times acceleration, which is gravity, which is 9.81. Remember, that's negative, so that's going to be pulling us down, times time squared, which is going to be 3 squared. So we have 9 times negative 9.81 times 0.5 equals, because this is 0 and this is 0, our initial velocity, which is a question mark, times 3. So then we'll divide that sum by 3 and we'll have that initial velocity. Now, the idea also is to look at this with the following, where we're going to use the joys of how we're going to be looking at doing this on another planet with obviously different amounts of gravity. Now, obviously, you guys aren't going to be in groups, but this is the basics of how we're going to break down essentially the distance and effectively how far things are going to be going. Now, one thing that's important is you're going to have to use that quadratic formula when we are trying to solve for time, because we have our A term, because that's going to effectively be the acceleration of gravity times 1/2, whatever we happen to be using at the time. And typically it's going to be obviously negative. Our B term is going to be our initial velocity, and our C term is going to be effectively where we're starting off the ground. So then we're going to utilize the quadratic equation, the quadratic formula, and that's going to help us solve for what we need. So hence why we have these wonderful equation slides that you're going to be using. So remembering again what the units are that we're working in. The example that we have here, folks, is if we start off going at 5 meters per second for 10 seconds, and we're deaccelerating at 1 meter per second for those same 10 seconds, how far would we have gone in the same period of time? So, and then effectively how fast we'd be going, and effectively we'd eventually be going at a negative velocity, so we'd be going backwards. So it seems like a lot, and that's okay. I want you guys to go through, re-listen to this a couple times, and then go ahead and run through those examples, and we're going to talk about those on effectively Tuesday whenever we get back. So this is the example. If we're trying to find the vertical velocity and the horizontal velocity when we were working with an angle of 30 degrees, if the initial velocity was 10 meters per second. So I want you guys to do the same thing, only with an initial velocity of 25. And then as well, I want you instead to change this total distance. You can feel free to change the time and then work out effectively what would have been the angle. Now, the component that we haven't done about the angle is once we have our vertical initial velocity and our horizontal initial velocity, now we can use tangent because we have our opposite and our adjacent. Our adjacent is going to be the horizontal in this example, and then our opposite is going to be the vertical initial velocity. So we have that divided by the adjacent, and then we take the inverse tangent. So that's going to be tan to the -1 that you see on your calculator, and that's going to allow you guys to find those values. So do your best. It's okay to struggle. If you're having issues with it, that's fine. Come with questions, and we're going to go ahead and talk through that whenever I see you guys on Tuesday. So have a great day, guys. Thanks for listening. Stay safe out there. Bye-bye.